2i. Alright, so number 35, I'm going to have to use the p's and q's again. So the p values are your factors of 16, plus or minus 1, 2, 4, 8, and 16. And for q, it's just plus minus 1. So that means that p over q is basically the p list, right? Because since q is plus or minus 1, it's this list right here. Alright, let's get started. Let's start off with 1. And again, I'll use 1 because there's pluses and minuses right here. So, you can start with any number, so I'll just start with 1. Okay, you set it up with synthetic division. Bring down the 1. 1 times 1 is 1. Negative 3, 5, 5, negative 11. It's not going to work, right? So you try 2. Try the next number on your list. 1, negative 4, 8, negative 16, 16. Bring down the 1, 2, negative 2. Negative 4 is 4. 8 is negative 8. And then negative 16. So we found it. We found 1. Okay, I still have a cubic function, right? It doesn't hurt, or it's always a good practice to try the number again, because the multiplicity of that 0 could be more than 1. So, and remember, we always use the reduced polynomial. Use these numbers. Don't go back to using these numbers, okay? Once you find a 0, use the new polynomial. So bring down the 1, 0, 0, 4, 8, and 0. So here we found it. So this means that g of x is x minus 2 squared, because there's 2 of them, and then x squared plus 4. So this being the sum of 2 squares right here, we're going to do what we did in previous problems, where you think of this as x squared minus a negative 4, and then you look for the square root of negative 4, which is 2i. So then you would rewrite it as x minus 2 squared, and then x plus 2i, x minus 2i. Okay, so the zeros are 2 and plus or minus 2i. Alright, for 38, they want you to find the zeros, write it as linear product of linear factors, and then give the x-intercepts. Okay, so replace this with 0. This is again a quadratic that does not factor, so we're going to use quadratic formula. So that's 12 plus or minus, now 144 minus 136, because 4 times 34 is 136, gives you 8. So remember, 8 is 4 times 2, so the 4 comes out. So you're left with 12 plus or minus 2 radical 2 over 2. We factor out a 2. So now I can cancel the 2's right there. So the zeros are 6 plus or minus radical 2. Okay. For part B, they want you to write it as product of linear factors, so you're going to write f of x equals, because it's a complex 0, you have to use the brackets initially, like this, and then x minus 6 minus radical 2, and then simplify this by distributing the negative. Like this, and here it is, f of x. And then for C, they want you to identify the x-intercepts. So because these are real numbers, 6 plus and minus radical 2, plus or minus, these are real numbers. So we just approximate them on the number line, and this is where the graph is going to cross the x-axis. So the x-intercepts are 6 plus or minus radical 2. Alright, 41. This one definitely I was going to have you guys skip it after I solved it myself without a graphing calculator and without, you know, any additional or extra resources. I just started doing synthetic division and everything till I found the 0. But this would be a good problem to use Desmos on, because that way you could see where the graph crosses the x-axis approximately, and then that would reduce the number of synthetic divisions you have to do. Because you know, as if you came up with your list of p-values, you'll see what I mean. Plus minus 1, then 2, 3, 5, 6, 10, 15, 25, 30, 50, 75, and 150. Thankfully, the Q value is just plus and minus 1. So this is our list of P over Q, the one that's on the screen. So I went through a lot of synthetic divisions before I came to the answer, because to the first 0. So that the one I found, and I'll show it to you right here, is a negative 6. This is the one that works. Okay, so you bring down the 1, you get negative 6 here, this gives you 36, and then this gives you 25, and then you get negative 150, and there is a 0. But yeah, I went through like 2, 4, 6, 8, like 9 before I came across this one. Again, that's just the way it is, right? So after you find that, this is a quadratic where we have to use quadratic formula to find the 0. And so you get, let me set it up. So you set up your quadratic formula, and this becomes 6 plus or minus, and so you get, what is it, 36 minus, what is it, 25 minus 100. So 36 minus 100, you get negative 64 over 2. So this is 6 plus or minus 8i over 2. We factor out the 2. And then the 2 over 2 is gone. So these are your zeros. So the zeros are negative 6 and 3 plus or minus 4i. So when you write it in as a product of linear factors, this is part A. Part B, you would say f of x equals x plus 6, and then x minus 3 plus 4i, and x minus 3 minus 4i. Distribute the negative, the negative to get rid of the brackets. X plus 6, x minus 3 minus 4i, x minus 3 plus 4i. So this is the factored form, the linear factor, product of linear factors right here. And then for C, the x-intercept, there's only one. The x-intercept is negative 6, 0. Because these are imaginary numbers, or let me go back. These two are imaginary numbers. They do not make the graph cross. There's no place for them on the x-axis because they're imaginary numbers. Okay, so this is the only x-intercept. All right, so for 44, the p-values are plus minus 1, plus minus 2, plus minus 4, plus minus 8, plus minus 16. So for part A, to find the zeros, I used 1, and it didn't work. So I don't know if I should just show you, but 1 didn't work. You get 1, negative 7, 10, 2, and 18. I tried 2 and it didn't work either. Whoops, positive 17, sorry. So we bring down the 1, 2, negative 6, negative 12, 5, 10, 2, and 4. 20 didn't work. I tried 4. Give myself less and less room. 1, 4, negative 4, negative 16, 1, 4, negative 4, negative 16, and finally this one did work. Then I tried it again, because remember, some could have more than multiplicity that's more than 1. So I tried it again, but I used the reduced polynomial. I did not use the original again. I hope that makes sense. So bring down the 1, 4, 0, 0, 1, 4, 0, and it worked again. So these three numbers right here, remember, mean x squared plus 1, right? So so the zeros are going to be 4, multiplicity 2, and plus or minus I, because that's what this gives you right here. So when you write it as in factored form, you're going to write f of x equals x minus 4, then x minus I, x plus I. So there it is as a product of linear factors. For C, the x-intercept, this one's only going to cross the x-axis at 4, because the other two are imaginary.